Hi everybody, welcome to another My Tutor online school tutorial. Today, GCSE Maths. So we're kind of continuing on from yesterday, if you came to that one. So yesterday we did the sine and cosine rule, and today we'll be looking at Pythagoras and area, and also Sohcahtoa as well. I forgot to put that on there. So a lot of triangle stuff. So we're going to kind of try to get through as much as we can. So this session is 1 hour long, so it'll finish at 4:15 p.m. This is me, Molly. I'll be leading this tutorial today. So I'm a second year computer science and maths student, and I've done over 200 lessons with my tutor, which hopefully means I know what I'm doing. So fingers crossed. Okay. So please make great use of the Q&A and the chat functions. Ask me throughout to speed up, slow down, or ask me to re-explain something or do another example or whatever. So let's go straight into it. So today the format will be, we're going to start off by talking about Pythagoras and what that is and how we use that. Then we'll talk about Sohcahtoa. If you don't know what I'm on about, that's fine. We'll learn that. Then we're going to talk about the area of right-angled and non-right-angled triangles. And then we're going to finish with a Kahoot quiz. So yesterday we tried a quiz on quizzes. So yes, we're doing a Kahoot. I'm hoping, so the Kahoots for tomorrow and Friday are a bit longer. This one isn't as long, but I'm hoping that it works okay. And that means that I can kind of see your live results coming in. And of course, as always, at the end, there's going to be a maths joke. So if anything keeps you going for the whole of this tutorial, let it be the maths joke. Cool, so I think everybody's here, so we're good to get going. So as promised, we'll start with Pythagoras' theorem. Now, a couple of things about it first. I always, when I go through this with my students, explain why it's called that. Basically, I think mainly the word theorem is a bit confusing sometimes. Basically, it's a guy called Pythagoras, this ancient Greek guy who loved maths, came up with this theorem. And all a theorem is a statement that is true. So it's a theorem that all of the angles in a triangle add up to 180 degrees. That's an example of a theorem that we might have. A couple of people are saying that it's freezing a little bit. I don't know why. Oh well, I'll just continue and assume that it's not. Yeah, so a theorem is just a statement that someone asserts and then it gets proven true. So that's all it means. So I feel like it sounds really fancy and like something to be scared of, but it's not at all. So what this says, so we're going to draw a triangle. Now, Pythagoras' theorem only works on right-angled triangles. So that's really, really important. The first two things that we're doing today, Pythagoras and Sohcahtoa, both only work on right-angled triangles. So where one of the angles is 90 degrees. So you can only use it for that. And the first thing that we do is we label the triangle in exactly the same way that we labeled it yesterday. So if you were here yesterday, you'll know that we labeled the sides with a lowercase a, b, and c, and then the angles with capitals. Pythagoras is just about the sides, so we're only going to label the sides, but it's a lowercase a, b, and c. And the important thing is that this c here is the hypotenuse. Another long fancy word coming from something Greek meaning something. But what it means is it's basically like the diagonal one, so the one that's opposite the right angle, so the line that's not making up the right angle in any way. Now this will always be the longest side of the triangle, and it's kind of, yeah, this special one that we label as that hypotenuse. So Pythagoras' theorem, as I'm sure you'll be familiar with, is this. It's that a squared plus b squared equals c squared. Nice and simple, drilled into your brains, hopefully, and everybody should kind of, yeah, gone through it. Someone said, does this get harder? Yes, we're starting off easy and working our way up throughout the lesson. Oh, someone says I keep freezing and the audio breaking up. I don't know whose end that's on. I think someone said to repeat the hypotenuse bit. So that's just the side that's opposite the right angle. So there are two lines that make up the right angle. The hypotenuse is the other one. That's all that is. So what this basically says, if you want to kind of see it in a visual way, is that if we have a right angled triangle, then it's saying that the area coming off this side and this side, so if we draw squares on these edges, the area of those light green bits is the same as the area of this dark green bit. So they're equal. So the sum of these two squares is this square. Depends how you want to think about it, whichever way kind of makes more sense to you. But this means that if we have two sides of a right angled triangle, we can always work out the third one. So that's super, super useful. So let's jump in with a question. Someone says that my audio keeps breaking up. I'm going to try plugging in another microphone just in case it's mine. So just give me one moment. I can't use the mouse, but.
Oh yeah, definitely, yeah. Yes, so that would have been Mary.
Let me know if this is better or worse, because I've tried putting on another mic, oh gosh, which I cannot use. So just let me know. Yeah, because I don't know whether that's better or worse. Okay. So we'll just jump straight in with a Pythagoras question. So again, I'm using Maths Made Easy, which I feel like I've probably gone on about 1,000,000 times because I think it's a fantastic website for worksheets.
Oh, right.
So we'll start off with one, for example, like this. I'll do this one here. So the question is just to find the side length of x. And actually what they should really have told us is that this is a right angle, because you can never really assume that something's a right angle. Okay, I think the audio is better now, which is good. So I don't need this now. Okay. So what we do is all you really need to recognize is which one is the hypotenuse, and that's this one. So the sum of the squares of the other two, so a squared plus b squared is equal to that, c squared. So that's what we do. So we take, so 8 squared is 64 plus 10 squared, which is 100, is equal to x squared. So x squared is equal to 164. And then we can find out what x is from that by just doing the square root of 164. So, 164 square, I'm going to use the online calculator that I used the other day on here. Because I liked this a lot better. There we go, nice. 12.8 to one decimal place. And you can see that, as promised, that is the longest side. But you can also tell that it kind of makes sense with the others. I think it's always good to do a bit of a sanity check with these. Because if we'd got something like 200 or something, that might be a bit of a weird length for this triangle to have. But 12.8 makes perfect sense, and that works with the rest of the triangle. Perfect. A couple of people got that. Yeah, that's the other thing. Feel free, if you haven't been here before, pop your answers in the chat as we go along, because it's really good to see if other people are getting it, and see if you challenge yourself to get it before I finished going through it. Okay, let's have a go another. I won't go over Pythagoras for too long unless people ask me to, because I'd like to go on to the trickier stuff, but we'll have a go. So let's do this one. So here, again, they haven't actually told us the right angle, but it will be here. And just like make a note to yourself which one the hypotenuse is. So here, what we're going to have to do is say, so a squared plus b squared, obviously it doesn't matter which one's a and which one's b, equals c squared. So here, it's not the equals x squared that we have. All that means is that we rearrange it slightly differently. It's nothing too different. So we work out 13 squared and 16 squared. And then to work out x squared now, instead of adding them, we're going to have to do 256 minus 169. So 256 minus 169. That gives us 87. hypotenuse. So then to work out x, we square root that. 9.33. And again, that makes sense because it's smaller than our hypotenuse, which we said would be the biggest, and it's kind of in the same range that those are in. So that kind of makes sense. Someone says, what does the word Pythagoras mean? That's the name of this Greek guy. Here you go. This dude who lived hundreds and hundreds of years ago and came up with this theorem. So yeah, I don't actually know what else he did, but he loved geometry, so that's who Pythagoras was. Interesting to read about. So I think I'll probably move on to Sohcahtoa, but please do shout if sorry, some people are saying that they can't hear me still. But please do shout if you can't hear me. Okay, so we'll move on to Sohcahtoa for now, but let me know if you would like to go through another question like that. Okay, let's have a look at Sohcahtoa. So I'll go through it before we jump into some questions. So what this is again for right angled triangles, but it's when you're looking at an angle involved. So Pythagoras is when it's just the sides involved, whereas Sohcahtoa is when we've got angles involved as well. So let's draw a right-angled triangle again. And this time what we do, so let's come up with an example question. So let's say we have, okay, can you not message the chat loads of times? Because I can't see what other people are saying if you message the chat loads. No. Yes, we are doing a quiz. So what we do here is we first of all, let me set up a question. So let's say that this is the angle that we're looking for, and we know that this is of length 5 centimeters, wait, right, the units, and this is of length 4. And we're looking for this angle here. So what we do is we first of all label our sides. So we label which one is the hypotenuse. So that's just what we were doing before with Pythagoras. And then we label the adjacent and the opposite. And what those mean is the adjacent is the one next to the angle. So the angle that we're looking for will always be made up partly by the hypotenuse, because it's never going to be the right angle, because we know what that is. And then the other line that makes it up, that's called the adjacent. So adjacent just meaning next to. And then the other one is called the opposite. And that's because it's the one that's directly opposite that angle. It doesn't make up that angle at all. So this is how we label them, H, A, and O. And the reason that we do these is so that we know which trig function to use. And I talked about them yesterday, and I'll talk about it again. So trig functions are nothing scary. It's sine, cos, and tan, or sine, cosine, and tangent, to give them their full names. And all they are is they're graphs that tell you how to map from one thing to another. So for example, sine looks like this, and then it carries on and on. So it goes up to 1 and down to -1, and along the x-axis here are degrees. So say you ask your calculator, what's sine of 30? All your calculator does is it looks at this graph, it goes along, it finds 30 degrees, and it spits out what that is. So if you do sine of 30, your calculator gives you 0.5. The reason is because if you go along here until you get to 30, the answer on the y-axis is 0.5. Okay. Someone's asking how to spell, are you asking how to spell Sohcahtoa? Because we'll come to that in a minute, I think. So yeah, this is a sine graph, and the other ones look kind of similar. The tan graph is a bit weird. Let me know if you want me to go over them. It's not exactly what we're covering today, but can be useful. So cos looks similar and tan's like this, but all your calculator's doing, the point is, when you ask it for sine of something or cos of something, and it spits out a value, it's just looking it up on this graph.
So I often think it's a bit weird because, you know, it's never really explained exactly what they're doing. But yeah. Okay. So we want to know how to use these. So this is going to, especially if you haven't seen this before, this is a weird concept at first, but the more you do it, the more sense, hopefully, it makes. So let's have a look at Sohcahtoa. So this is what Sohcahtoa is. Now it looks really weird, but all we think of this is as these three kind of groups of three. And all this tells you is you work out which kind of out of O, A, and H you have. So here we have O and we have H, right? We don't have A, we know nothing about this side. That's not involved in this calculation at all. We're only looking at the opposite and the hypotenuse because we have those. We know that they're 4 and 5 respectively. And because we've got O and H, what that means, we look it up in Sohcahtoa and see that here is where O and H appear together. Now you see each of these is a different combination of O, A, and H. So you've got O and H, A and H, and O and A. So hopefully you can see where I kind of got that from. And because it's So, this represents sine. So this represents sine, cosine, and tangent, sine, cos, tan. Yeah, so depending on the different pairs that you have, you use a different trig function. And hopefully that makes sense. Someone's asked me to explain which side is what. I'll explain, when I do the next one, I'll carefully explain it again. And then, and this is the important bit, is how to actually use it. We set up the same equation every single time. And it follows this format. The trig function that we've decided on of the angle is equal to this over this. So for example, in this case, because we've decided on sine, it's sine of the angle is x, is equal to this over this. So I mean O over H. So that's 4 over 5. So sine of x is equal to 4 over 5. And hopefully you can see why we've set it up that way. And if not, don't worry, because we'll be doing loads more examples. And I think the more you do, even if what I'm saying doesn't make sense, you'll kind of pick up the patterns and see why it is like that. Now what we have to do is then get x out of this. And I talked about this yesterday when we were doing the sine and cosine rules. We have to do inverse sine. So when something's, so say this said like 3x, that's being multiplied. So we do the opposite and we divide by 3 to get x out. Now this has like sine applied to it. So that's kind of weird. We can't like divide by sine because it's not being multiplied. It's being like applied to it. So we do what's called inverse sine. It's exactly the same as dividing to get rid of a multiplication or adding to get rid of a subtraction. We're inverse signing to get rid of a sign. So what that means is that x is equal to the inverse sign, which we write like this with a little -1 up there, of 4/5. So hopefully that makes sense. As I said, it's like dividing by 3 to get rid of a multiple of 3. We're just applying inverse sine to get x out of the sign. And on your calculators, you'll have, it's normally going to be like shift sign or something like that. But you'll have a function that lets you do inverse sine. So inverse sine of 4/5. So I'll show you on here on this calculator. On here you press inverse and then sine. See, it came up there as sine to the -1, and here it's called arc sine. That's the same thing. If you ever see that online in a question or in a paper, arc sine, arc cos, arc tan, they're all the same thing. They all just mean the inverse of these things. So arc sine of 4/5 or 0.8 is this. Oh, no, it's not. I did the same thing yesterday. I have to switch it to degrees. There you go, it's this. So 53.13 degrees. Or just 53 if we're just doing it to one decimal place. So x equals 53 degrees. And again, just looking at this, we can kind of see that that's sensible, right? Because that kind of, yeah, looks like a 53 degrees there. Somebody said, does it get harder than inverse sine? That's a good question, actually. I'm trying to remember what's covered in GCSE. I don't think so. You obviously have harder questions where you have to deal with it. But in terms of working with trig functions, yeah, someone said shine, which is a different, I don't know, I think that's further maths or A-level though, I think. For what we're doing today, at least, and this week, it doesn't get harder than inverse sine. So let's have a go at a question like this. I'll grab up these. Let's go for these level 6, 7 ones. Try to get one here. Cool. Let's do this. So we want to find the size of the angle marked X. So we can see this is really similar to before. We've got a right angled triangle. And the way that you can tell that you need to use Sohcahtoa, if you remember that flow chart that I showed you yesterday, basically all it was if it's right angled, if it's got any angles in it at all, you need Sohcahtoa. If not, it's just Pythagoras. So hopefully you can see that it's right angled. We're talking about an angle, therefore it's got to be Sohcahtoa that we want to use. And whenever you know that you've got to use Sohcahtoa, first thing you do is label all of your sides. So the way that we label them is that we call this one the hypotenuse, and that's just like when we were doing Pythagoras. Remember, we called that one C, because it's the one that's opposite the right angle. It's the one that doesn't connect to the right angle in any way. And then the other two, the one that's next to the angle, so the angle here, and by the angle I mean the one that's in question. You know, so we've got two sides and an angle in question, so that's what I mean. So the angle here, can you see it's made up of a hypotenuse and this line? Therefore, we call this line the adjacent, because it's adjacent, which just means next to the angle that we're talking about. And then the final side, we call the opposite. And that's because it's opposite this angle. You know, if you kind of draw a line directly to it, that's the one that is opposite. I talked more about that yesterday when we were labeling triangles with their opposite angles. This is the thing that we were doing there. Someone said, what is Sohcahtoa? It's just a way to remember which trig function you use for each pair of sides that you have. And the more questions that we do, the more that will make sense. So the next thing that we do is we write out Sohcahtoa. So Sohcahtoa. And we work out which sides we have. So if you look here, we've been given this one and this one. These are the two. We're not thinking about the opposite at all, right? Because we don't know what that is. We're thinking about these two sides and this angle. So we're thinking about the hypotenuse and the adjacent. So H and A. And then remember, we think about Sohcahtoa as being split into these three triples. It's kind of like we're either using the So, the Ka, or the Toa part of it when we have a look. So here we're using A and H, and see here they appear together here. If it was O and H, like last time, we used sine. If it's O and A that we have labelled, we use tan. But it's A and H, so we're going to use cos. So that's all Sohcahtoa tells us. It's just a way of remembering which trig function we use for each one. Someone said, what's A? That's the adjacent. Let me write that out here. Adjacent. So next to, the one that's next to the angle. So now that we've chosen our trig function, remember we're going to do exactly what we did last time. We write out that equation in exactly the same way. So it's trig function of the angle is 1/2. So I'll show you what I mean here. So we say trig function, so this time we've decided it's cos, of the angle, so the angle in question is called x, equals, and then by 1/2, I mean this first one over this second one. So A over H. And what's A? It's 8.2. And what's H? It's 10.6. So A over H. A over H. So hopefully that makes sense how I set up that equation. And then remember, to get x out of this, we're going to apply the inverse. So how do we uncos something? We apply cos inverse, just like we did last time with sine inverse. So x is cos inverse of 8.2 over 10.6. And then we can just put that straight into our calculator. And I'd really recommend putting it in before you work out what 8.2 over 10.6 is. Like I was saying yesterday, you won't get any rounding errors if you just put it all into your calculator in one go. So it's a really good idea to try to, work that out first. So 8.2 over 10.6. So what we do is we inverse cos of 8.2 over 10.6. That's all we do. And it just spits out our answer. Because what our calculator does is it does whatever. So what the inverse is, if we look back at this, our graph, so this is with sine, but we give it our value, so say 0.5, say it's the opposite of this. It finds 0.5 and finds the first value and goes, oh, to get 0.5, you would have had to put in 30. And here, to get whatever 8.2 divided by 10.6 is, we would have had to put in 39.3. So that's the degrees, that x-axis value that we put into our cos function to get out this value that we receive. So it's 39.3 is what x is. 39.3 degrees. And again, you can just look at the diagram, and even though it's not drawn to scale, you can tell it makes sense because of just kind of looking at it. You know it's not going to be anything bigger than 90 because otherwise it wouldn't be a triangle. So you know it makes sense. Okay, perfect. Look. Yeah, brilliant. Okay. A couple of people have recommended a different method of remembering it. I don't know any others. Oh, sorry, I just hit the mic. I don't know any others, so I will only be going over Sohcahtoa just because I'd get confused and therefore I'd confuse you guys. So we'll just do it this method. Okay, let's have a look at another one. Let's have a look at maybe when we want to calculate a side length. So let's have a look here. So another right-angled triangle. And again, regardless of which one is labelled as the unknown, we've got an angle and two sides. And because we've even got an angle at all, we know it's going to be Sohcahtoa. So we know we label our sides straight away before we do anything else. So we label this one is the hypotenuse, this one is the adjacent, and this one is the opposite. Hopefully you can see that because this one's the adjacent because it's the one right next to the angle that we're talking about. And this one is opposite the angle that we're talking about. So now we write out Sohcahtoa. And we remember that this is just representing 3 sections. And we work out which ones we have. So we definitely have this one, right? Because it's 12.5, that's A. Even though we don't have this one, it's the one that we're looking at, right? So we kind of know it's Y, if that makes sense. So this counts as the one that we're looking at. So even though it's not that we 100% know, it's the thing that we're looking at. So that's what it counts as. So in this case, now we have O and A. So we see where they appear, and therefore we know that we're going to be using tan, because that's the triple that it's appeared in. So we're going to write out, regardless of where Y is, even though Y is not the angle, we write out the same equation. Trig value of the angle equals 1 over 2. So trig value, tan, of the angle, so the angle, remember, that we're looking at is 40, equals 1 over 2. So Y over 12.5, because it's the opposite over the adjacent. And hopefully that makes sense. Okay, a couple of people have said that they find Sohcahtoa confusing. I don't know another way to do it, and I really do believe that this is the easiest way to do it. All it's telling you is you look up which 2 sides that you have, pop it in here, and it tells you which trig function to use. That's all it is. It's just a method of remembering which one it is that it goes with. If you want to do it without Sohcahtoa, you kind of need to memorize them. So yeah, Someone said, are these similar to questions in the exam? Yeah, these are really similar to questions in the exam. In fact, you could get exactly this question. Okay, so let's pop back to this. So we've got this and we want to rearrange to find what y is. Now, all we want to do is just get rid of this 12.5. So we can just multiply up by it. So we see that y is 12.5 lots of tan 40. All I've done there, I mean, I've swapped around which side of the equals I've written it on, but that doesn't matter. We're allowed to do that. So I've just multiplied up by this 12.5 to get rid of it. So now y is equal to 12.5 tan 40. So let's pop that in. And there we go. We get 10.5. And that makes sense. We can kind of see that that works. It looks about right for our thing. So it's 10.5. Cool. A couple of people got that, which is really good. So I hope that makes sense. We're going to do a couple more, don't worry. I'm just making sure that I have time. I think I'll do one more and then go on to area. And then when we do the quiz, I'll go through the examples that we have on there. Okay, so let's have a look at finally, I want one where it's the side again. Cool. So this one's asking us to calculate the length of AB. So that's what we'll do. So we've got this one here. And it's a right angled triangle. So even if it probably won't tell you to use Sohcahtoa, but again, we see it's right angle. We see it's got an angle in it, so we know it's Sohcahtoa. So the first thing we do is we label our sides. We know that this one's the hypotenuse. This is the adjacent because it makes up this angle. Oh, sorry, I didn't actually label which one was x. We're being asked to find this side here, AB. And this one's the opposite because it's not linked to the angle at all. It's just dead opposite it. So we've done that. We're going to write out Sohcahtoa. Sohcahtoa. Remembering that this is just in some triples, let's look at which ones we have. We have A and we have H. Those are the two sides that we're looking at. So where is A and H? It's here. So that means we want to use cos. So we set up our equation in exactly the same way. Trig function of the value is 1 over 2. Trig function that we've chosen is cos of the value in question, 58, equals 1 over 2, so A over H. By 1 over 2, I mean the order in which it appears in Sohcahtoa. So A over H, so x over 16. And then rearranging in exactly the same way as we just did, we get the x is 16 cos 58. So let's see what that is. 16 cos 58, 8.478 or 8.48 if we're doing it to 2 decimal places. X is 8.48 meters. And again, that seems to be around the same size as the other length, so that makes sense for us. Yeah, that does say 16. Sorry, someone asked if this said 16. Yes, I just drew it very, very badly. And yeah, a couple of people got that right in the chat before I'd finished going through it, which is awesome. Someone said, can you use Sohcahtoa with any triangle? No, this only works with right angled because you can't label the hypotenuse if it's not a right angled triangle. The hypotenuse is defined as the side that's opposite the right angle. So if it doesn't have a right angle, it doesn't have a hypotenuse, so you can't use Sohcahtoa. For non-right angled triangles, you do what we did yesterday, which was the sine rule and the cosine rule. Hopefully that makes sense. Okay, so do let me know if you have any questions. I'll be coming back to it at the end. I'm going to cover area now for about 10 minutes, and then we'll be doing the quiz. Because the quiz is kind of encapsulating everything that we did today, so that's why it will be at the end. So, okay. Let's first of all think about the area of right-angled triangles. So, if we have a triangle like this, does anybody know the general kind of formula for finding out the area of a triangle? a right-angled one? So pop it on the chat or the Q&A. Yeah, cool. A couple of people have got it. Okay, yeah. So it's half, yeah, of the base times the height. So we call this length here the base length. This here is the height. And it's the perpendicular height. So this does actually work for any triangle as long as you know the perpendicular height. What that means is the height from the bottom bit to the top peak. So if we have a triangle that's not right-angled like that, we can still work it out because this is the base and the perpendicular height is this here. You don't always know that though, you'll probably just know side lengths and that's when we'll come to a different formula in a moment. But yeah, lots of people got that, which is really fantastic. Okay, so let's just do a couple of examples of that. So let's say we have this triangle where the base length here is 4 and the height is 5, let's call them meters. What's the area of this triangle going to be? Cool, someone's already got it, that's fantastic. Yeah, more people have got it, fantastic. Yeah, brilliant. So what we do is we take half times the base times the height. So half times 4, that's 2, times 5 is 10. So it's 10 and it's an area, so it's meters squared. Okay, brilliant. What about if we had a triangle like this, where we're told that this length here is 6, and this length along here is 12. What's the area of this triangle going to be? Yeah, someone also said, can't you do 5 times 4 and then divide that by 2? Yeah, because it's like a half or divided by 2, that's the same thing. And times base times height, because it's all multiplied, you can do it in any order. And I'll show you a couple of different orders that you can do for this one. Brilliant, a couple of people have already got it. Sorry if I'm not giving you long enough. Hopefully when we come to the quiz, you'll have long enough to do it. So the area here is half times the base length times the perpendicular height. So if we, luckily here, I didn't kind of throw you off by giving you a side length, but it's always, yeah, this height from the bottom to the top point where this kind of, and it's called the perpendicular height because it will come up from the bottom at a right angle. So perpendicular, that's why it's called that. And here we can do a couple of things. We can either do half times 12, which is 6, and times it by 6. We can do half times 6, which is 3, and times that by 12 to get 36. Or we can do 12 times 6, which is 72, and divide it by 2, which is 36. And each time we get 36. I didn't give this any units, but it will be something squared, whatever the units happen to be. Cool. Well done. Okay. Yeah, sorry, I didn't give the unit on this one. I should have done. And finally, just as a bit of a challenge one, what if we had this, where this, right here, this is 10, this is 12, and draw on here, this is 8. What's the area here? Oh, brilliant. Yeah, loads of people getting it straight away. Not fooled at all. Oh, I didn't do units again. I'll say that they're centimeters. Centimeters. Loads of people getting this one. Well done. So all you've got to spot is that the perpendicular height, even though it's not drawn inside the triangle, it's drawn outside, it's still the perpendicular height. This is pointless. This is just here to throw us off because we know this. We do half times base times height, and that gives us 40 centimeters squared. Okay, perfect. So what if we don't have the perpendicular height? What if we have a triangle that looks like this, and we're given that this angle here is 30 degrees, and we're given that these side lengths are 4 and 5, but we're not given the perpendicular height? What we have is a formula that we can use for any type of triangle, and it uses one of our trig functions. Does anybody know what that is? Don't think so, maybe not, so I'll go through it now. So what it is, I'll just kind of write it out and then explain which is which. So the area, I'm actually going to write area so that we don't get confused with labeling the triangle, is half AB sine C. So what this means is, again, we label our triangle in the same way. So we call the sides A, B, and C in whichever way we want, and then the corresponding angles, the capitals of this. In this, we don't actually use this one, or this one. So what this means is it's two sides and the angle that's inside them. So I never really think about the labeling too much. I just think that it's half of the two sides and the sine of the angle in between them. So let's have a look with this example. The area here is half times A, which is 4, times B, which is 5, times sine C, which is 30. So it's literally just plugging numbers into a formula again. So this is going to give us, well, half times 4 is 2, times 5, and sine 30 is 0.5. That's one of our kind of key values, you know. So 2 times 5 times 0.5 is 5. So this is 5. I didn't do a unit again, but we'll pretend it was meters. And there we found the area of this triangle without having the perpendicular height. Okay, cool. So I think we'll go on to the Kahoot quiz now, because we've only got 15 minutes and I want to have time to do it. So either open up your apps or do kahoot.it on the internet. Oh no, I need to get my account up. Ooh. I don't want to upgrade, go away. Oh my gosh. Just let me play my Kahoot. There we go. Okay. It's crossed, classic. There we go. Okay, so here's the game pin for it, 542211. So log in on your mobile phones, on your laptop. It's Kahoot, so it gives you the address up here, or you can go onto the app if you have it. Cool. A few people are almost in. So yeah, okay, I think there are 26 students here. So yeah, I'll try to wait until we have that many. I don't want anyone to miss out, but also I don't want to wait too long. Is anybody still waiting to join? Okay, some people are still waiting. Okay, anybody else still waiting? Okay, I feel like that's everyone who's gonna, oh no, someone just joined. Okay, Oh gosh, more people keep joining when I'm about to start it. Okay, I think I'll start it now. If you haven't joined, then okay, wait. Wow, I'm hurt. Okay, I'll start it now. If you're still waiting to join, if you don't get a chance to join, just like play along with yourself. I'll leave the questions up. So I think I gave like a minute or a minute and a half to answer each question. So let's go. Okay, here's the first one. Okay, yeah, perfect. Most people got that. A squared plus b squared equals c squared. Okay, so if you know the hypotenuse and the opposite side, so the h and the o, which trig function do we use? So this is thinking about Sohcahtoa and which one we choose there. Yeah, brilliant. Majority of people got that one. So because we know the hypotenuse is the opposite, that's O and H, so it's the SO part, which means that we take the S, the sine. I'm glad I hate maths is the highest climber. Okay, so we're going to get a diagram and work out what the area of this triangle is. Perfect. Almost everybody got that. Yeah, so it was just, look at the media, half times the base times the height, so half times 8 times 10. Fantastic. I think there's only, okay, so there's 2 more questions left. So we want to find y to 1 decimal place in this diagram that's going to come up. So this one you've got 2 minutes for, because it's a bit of a harder one to work out. Well done, whoever submitted that super quickly. That's really good. I think most people are there. There's just a few more. I'll let it go. Oh, okay. Everybody answered that. Okay, brilliant. So just about the majority of people got that right. So let me show the media and I'll explain. So this side here, the y, is the adjacent and the 12 is the hypotenuse. So we're looking at a and h, so we're using cos. So then we set up our cos 38 equals y over 12. So y is 12 cos 38. So have another look over that one if that's one of the ones that you got incorrect. And our final question here, we want to know what the value of x is in this diagram. Okay, most people have answered, just a few more. I'll just let it run all the way down so that everybody gets a chance to answer. Brilliant, almost everybody got that one, that's perfect. So this was a Pythagoras question. So to find x squared, we have to do 10 squared minus 6 squared. So that's 100 minus 36, which is 64. Square root that and it gives you 8. So again, have another look at this question. This is all recorded, so have another look if that's one that you got wrong. Fantastic. That's the end. So here are the winners. So in third place, Jack. Second place, Kim is dead. And first place, H. So you all got 5 out of 5, so well done. And I think a lot of people got a lot of those right. So well done, everybody. And as I said, now that I know that that kind of works, the ones for tomorrow and Friday are quite a bit longer. They're 10 and 8 questions. So yeah, hopefully that all works. Yeah, already got them there. So yeah, please do let me know on the chat and the Q&A. Did that work better than the quizzes yesterday? Is that something that you'd like to see more of? Let me know, because feedback is always very good. Okay, so we've only got 5 minutes or so left. So what I'm going to do is I'm going to go over one more type of question. So do let me know if there is a specific question that you would like to go over. If not, I'll just choose any kind of Sohcahtoa one. Yeah, a Sohcahtoa question, cool. Someone suggested that. Also, whilst I'm doing this, if you're already comfortable with it or whatever, feel free to send me maths jokes if you want to keep your brain busy. We'll do that. Okay. So let's draw ourselves a right angled triangle. And let's give ourselves an angle here. Oh, in fact, I don't want that because that means it's isosceles, too easy. Okay. 55 degrees. And then let me just work out what I want. So we're going to have this one is x. And let's have that this side here is 7. And we want to know what x is here. So again, we know that this is Sohcahtoa because it's got a right angle. And it's got an angle in the question, so it can't be Pythagoras. So the first thing that we do is we label our sides. So here's the hypotenuse, because it's the long diagonal side opposite the right angle. Here is the adjacent, because it's the one next to the angle that we have. And here is the opposite, because it's the one opposite the angle that we have. Then we write out Sohcahtoa. And we look at which sides we have given. So it's this one and this one. And by given, as I said, it can be x, it can be the unknowns, but basically the two sides in question. And it's O and it's H. So we're going to look here, there's OH. So that means we're using this triple here, so we're using sine. So we do the equation in the same way every time, remember, don't forget it's trig function of the angle 1/2. So trig function, we've decided it's sine of the angle is equal to opposite over hypotenuse. So the reason that I chose this one is because it's a bit harder to rearrange because we've got an x on the bottom here, if you can see. So this is, I guess, the hardest type, so I saved it for the end. So what we're going to do first of all is multiply up by this x. It gets rid of the fraction and makes it all nice and kind of linear so that we can see it in one go. So then we get x sine 55 equals 7. And then to find x by itself, we're going to divide the left and the right-hand sides by sine 55. So we get x equals 7 divided by sine 55. So then we can do exactly that. I'll hop over to the calculator here. So 7 divided by sine 55. So 7 divided by sine 55. And that gives us 8.55 if we round it to 2 decimal places. 8.55. So x is 8.55, whatever unit. I should have written 1 centimetres, millimetres, metres, whatever it happens to be. So that is the hardest type of question because of the rearranging that's involved in it. Okay. Okay. So we've just got 2 more minutes, so I'm just going to review everything that we've done today. Sorry, I'm just looking through the jokes, and then we'll do a math joke. Okay. So we've gone over Pythagoras. So that's when we're looking at a right-angled triangle and we're just looking at side lengths. Sohcahtoa, when we've got a right-angled triangle, but we're looking at an angle as well as some sides. And areas, both of a right-angled triangle or one where you know the perpendicular height, and a non-right-angled triangle using half AB sine C. Okay. Okay, there's a couple of good ones on here. So I'm going to go for this one to finish off today. Never trust maths teachers who use graph paper. They're always plotting something. So there you go. Thank you all very much for coming today. Be sure to check out the My Tutor website. We offer private one-to-one tutorials if that's something that you're interested in. So definitely check that out. All of these tutorials, all of these live lessons are uploaded to YouTube. So check out the YouTube page if you've missed one or want to review this or anything like that. And check out the timetable for more exciting lessons that we have coming up. And I personally will see you tomorrow for circle theorems. So thank you very much for coming, everybody. Bye.